Everybody, my name is Dane McDonald. I'm going to adjust my lighting a little bit here. Okay. My name is Dane McDonald, and we're going to talk about multi-engine constant speed propellers. And I'm going to assume that you all already know a little bit about how constant speed propellers work. It uses a governor to regulate oil pressure, which changes the pitch of your blades. And the multi-engine is no different than that. It just works kind of opposite to what you're used to on the single engine. So same thing, right? You've got an oil sump. Oil's flowing up through here. You've got a pilot valve here that's controlled by your governor, which regulates the amount of oil going to your hub or away from your hub, right? And you've got a pump as well to boost the oil pressure to make the pressure strong enough to change the pitch in the blades, right? Same thing as you're used to on the single engine, but in the multi-engine, the oil pressure is used to drive the blades to a finer pitch or a higher RPM setting instead of the low pitch setting that the single engines or single engine constant speed propellers are doing. So why does multi-engine do that? Why does it work kind of opposite to a single engine? It's because when we're talking about multi-engine, it's all about how you handle the drag and kind of adverse control effects of when you lose an engine, or if you lose an engine, how you're going to deal with that. And the multi-engine constant speed propeller helps you out with that, because if you lose the engine in a single engine, your prop will just keep windmilling here, right? It'll be this big old drag disc. When you lose oil pressure, it goes to a fine pitch or high RPM position. In a multi-engine, it goes to a low pitch or low RPM, right? So it cuts down on that drag. And ideally, when you lose an engine or you demonstrate losing an engine, instead of having that big disc, you're just going to have these 3 blades right here, 2 blades, whatever you're flying. 2 or 3 blades, that's a lot less drag than as opposed to a big spinning disc here, right? And it really helps you maintain your control of the aircraft and lets you get better performance, climb performance if you can climb where you're at, or less descent perhaps. Maybe you'll just have a lower descent speed when you feather that propeller. So the multi-engine. So same thing, right? We've got our oil flowing up through here into the hub. We've got our governor. When the multi-engine, when you want to go to a fine pitch, you'll have more oil pressure in here. It'll come into your hub, drive your blades to a fine pitch RPM position. And when you lose that oil pressure, let's say you lose the engine, the additional part you're going to have here in the multi-engine. In mine specifically, I've got this is an N. It looks backwards here, but this is an N for nitrogen, right? My propeller dome is pressurized with nitrogen. So if I lose oil pressure, that nitrogen will drive the blades to a coarse pitch or low RPM position. And that will reduce the drag, right? It'll cut down on your windmilling and propeller. And then part of your job to help that propeller out is pull your control lever to the feather position, and that'll allow all the oil to flow out of there and for your nitrogen to drive it into a feathered position. Feathered meaning your blades are really coarse. Instead of your blades being at this angle, when they're feathered, they're more like that, right? So the wind can flow easily over that. This is a lot bigger drag surface and the windmilling of the propeller, that sort of thing. So that's kind of the additional part that you'll have here in your multi-engine. A lot of them have springs, a really high tension spring to push that piston and drive it into the low RPM position. My aircraft has nitrogen in it. Piper 34 Seneca PA34 200 has nitrogen to drive those blades towards the coarse pitch or feathered position, right? Another additional thing to think about when you're talking about multi-engines is these little locks. I wasn't prepared enough. There we go. All right, we got life. So there's these little locks inside, right at your blades, that will keep it from feathering in an intentional engine shutdown. Like when you shut down the engine, you're done flying for the day, you go taxi to your parking spot, you shut down the engine. There's no oil pressure, right? You shut down the engine, no oil pressure. But the manufacturer designs it with these little pins in place to keep the blade from feathering completely, because when you start up the engine when you start up the engine with the propellers feathered, and it just creates a lot of extra vibration and that sort of thing when you're starting your engine. It's kind of imbalanced and a lot of vibration. So they put these pins in place so when you actually shut down your engine and you don't pull the prop control lever to the feather position, they'll just go to a certain blade pitch angle that the manufacturer likes for engine startup. And excuse me. Oh, pardon me. Hope you have your masks on. And so why does that matter to us? When we actually have an engine failure in flight, we want the blades to be feathered, right? So we can have that really low pitch, or coarse pitch, low drag position. We want those blades to stop spinning. We don't want them to be windmilling, creating a lot of drag on that dead engine. So it's our job to help that propeller get to the feather position before the RPM decays to 800 RPM. That's kind of the big number according to the Airplane Flying Handbook. And it's also in my Seneca manual as well, 800 RPM. That's you need to feather that propeller before you get to 800 RPM, or else these little centrifugal downlocks will slide into place and keep you from feathering the propeller. When your engine RPM is above 800, these little propeller locks are out due to centrifugal force. The high RPM drives these little locks outwards or slings them outwards. So when you pull that propeller to the feather position, it will be allowed to feather. If you let it decay below 800 RPM, the centrifugal force is a lot lower. Those little locks slide into place and will prevent you from feathering your engine. And that's not good, because you need to feather that engine, or else you're going to be creating a lot of extra drag, making it a lot harder on yourself, and increasing your VMC speed. So that's pretty much all I have for you. It works the same way, except just a little opposite. Well, the exact opposite of what your single engine is going to do. Oil pressure drives the blades to a fine pitch. And when you lose your oil pressure, that nitrogen or spring force is going to drive your blades to a coarse pitch. You need to feather it before you get to 800 RPM. And that's about all you need to know.